Hey everyone, and welcome back to the Build Your Own Tezos Token workshop with Tezos Israel and MadFish.solutions. It's day 3, the last and final day, and I hope you guys have done your homework, thought about your competition pitch proposals. Please send those in PDF, by the way. I forgot to mention that until later. So if you're going to send that in, please do so on a PDF. There's no limit on how many pages. Don't worry about it. We're setting the deadline for Monday so that you guys will have time to properly go over it and think about what you want to put down. Don't stress about time. Go to work. Have fun with your friends. And don't have to, pound a Red Bull in order to get this finished by today. So, send those in and we'll get back to you about them sometime next week on our winners. And as the little hint that I put on Twitter earlier, nobody's checked I guess I can't actually ask you a live question because we can't see you. But last night we led a round of a toast for a very special event on Tezos, where we launched the first digital certificate on mainnet for the Tezos network. And it's pretty fun to say that. It was pretty cool to watch that happen. But you guys and girls, will be the first people to receive a certificate of accomplishment for completing this course on Tezos. There's going to be a 20-second delay till I can see the chats come in, but this is pretty cool. It's a first on Tezos, and we were really stoked to have this happen. So without further ado, Anastasiia, the floor is yours.
Thank you. So today is our last session, and I hope we will summarize everything we expected to learn during this course. And I guess we will apply all the knowledge that we have received. Let me share my screen. And today we will extend the project from our first session with new functionality, and we will build yield farming just with our FA1.2 token. We will add 2 more functions, Stake and Unstake. And when the user will put his tokens to our pool, I would say he make the stake. We will generate some rewards each second for him. And when he wants to put his tokens back to his balance, he will call just Unstake function and receive his tokens back to his main balance. That is actually our goal for today's session, and we will update migrations and make some tests. We will use some awesome project, which is called SushiSwap, that works on Ethereum blockchain as a reference implementation. We will look through this contract and understand how we actually can implement staking and unstaking on our contract. This contract is called Master Chief, and it can be found on SushiSwap GitHub. If you're familiar with Solidity, it will be easier for you to read this. But even if you don't, I think it's really easy language to look at it and realize what is actually happening here. Yeah, so let's start with deposit function. And that's this function. I would choose it. Yeah, we can see that there are some structures. One is called pool info, another one is called user info. The idea is that this contract is designed for staking many type of tokens. I mean, you can put one ERC20 token, another ERC20 token. So they have different pools for each token to stake. Also, they have such a structure as user info for each user and information about them. We can find these structures a little bit above of this code. It's somewhere here. Yeah, so in user info, we have amount, the amount that is staked in this pool by the exact user. And reward depth, it's really tricky variable. I will explain what is that a little bit later, yeah. But you should know that we need both of them in our implementation that we will write soon. Also, we have such a structure as pool info. As I said, this contract is designated for many tokens that can be staked on this contract, but we will stake only our own token on our platform. So we won't need at least two of these variables, which is LP token and allocate point. We won't need them. But we will use a last reward block. That is the last moment when we have updated rewards, when we have distributed these rewards, because we should know that we have how many tokens we should distribute during some period. Yeah, so it's the last time when we have updated rewards. And there is such a variable or such a field in pool structure, which is accumulated sushi per share. That is the amount of reward that is accounted for each staked token. That means all the reward that is designated for one single staked token in the pool. Let's imagine that we have 1,000 tokens in our pool, and we have 1,000 tokens for reward. Then we can split this 1,000 to another 1,000, and we will have one reward token per one staked token. That is the point of such a field. And this accumulated sushi per share will grow when we distribute more and more reward. Now let's go back to our deposit function, which is right there. And we have a withdraw function right there. They both start with such a function as update pool, because we need to keep the state updated before doing any action for user. That's why we will consider it before looking at all the other code. Update pool is this function, yeah. And basically we check whether we need to update the reward, whether some time has passed, and if no time passed, so we do not need to distribute new tokens, then we just return from this function. But if some period has passed, then we need to check if some tokens have been staked. LP supply is how many tokens had been staked in this pool. Then if there is no tokens, we also do nothing, but update last update time, which is here last reward block. But as soon as in Vigo we won't have an ability to know the height of the ledger or to know the block, that's why we will use time in seconds. And then we see the multiplier. It is a special variable that's calculated in a different function, but in fact it's just how many. It's a special multiplier that impacts on how many tokens should be distributed from the period that had passed during this delta time, I would say. And here we have sushi reward. We multiply multiplier to sushi per block. Then we multiply it to some other stuff, but we won't need it in our solution because our solution will be much, much simpler. So in fact, this is just the rewards that should be distributed during the delta time. Then we see that some reward goes to treasure, some reward is minted exactly to this contract, this pool, that, and then it would be distributed. And we see that such a variable as accumulated sushi per share, the reward per each staked token is updated. As you can see, it's always grows. So we add sushi reward divided by staked tokens to their previous value. As you can actually realize, we have a new generated reward. We divide it to all supplied all staked tokens, and this small value adds to the previous value of accumulated sushi per share. And we shouldn't forget to update last reward block. And in our case, it will be just last updated time. That's all what update pool reward does. Yeah. So it's used to update the state and to distribute reward. But as you can see, we do not update anything for the user here. It just functions and is designed to update the contract storage itself and to accumulate and distribute reward. Here, if we go back to the deposit function, we see another block of code, this one, which is used to distribute user reward if he has some amount on his stake balance, on his stake, yeah. So to do that, we multiply his current amount to reward per token, or accumulated sushi per share, and we subtract some special variable reward debt. Once again, I will explain it a bit later, actually in this line of that. That is amount of staked tokens multiplied by current accumulated sushi per share. And if you are curious why we need this variable, you can look at this line and realize that when we multiply current amount to our current accumulated sushi per share and subtract the previous reward debt, we actually have something like user amount multiplied by delta of accumulated sushi per share of the period that had passed from the last time when the user updated his reward. And when actually we have updated the reward for the user, we send this reward to his address. And that is all related to updating the reward and distributing reward for one single user. Then we have another block, which is this one, and it is used to put user tokens to his staked balance. So here we just transfer tokens from the user to our pool, and we update his record in our contract. And in the end of all of the story, we update reward debt to keep to fix when the user updated his reward, and in order to use it to calculate his real reward next time. Withdrawal function is quite similar. We also started with updating the state, with updating pool. Then we calculate the reward that the user should receive, if any. Yeah, and we check whether we need to send him some tokens or not, because he provides amount that he wants to withdraw. And if is any amount that he wants to withdraw, we send it him back. And again, we remember to update reward debt in the end of this function. And today we will implement these two functions in Lego, yeah, and test it. Do you have any questions related to the logic of how it will be implemented? Well, I see no questions so far. I think we can move on, right? Yeah, so here I just have our initial project with all we have done during the first session. With one change, which is this line. As we discovered during the previous lesson, there was a tuple when we have updated we have used their own balance. And everything else is just, as you can see in our main branch on the GitHub. Yeah, so now we will just define two new types for new entry points. And one type will be stake type. And it will be of type NUT. And then stake type also of type NUT, because we need to know how many tokens the user wants to put or to stake in our protocol. And Unstake also requires value in order to know how many tokens the user wants to withdraw from their protocol. Also, we define two entry points here. Right. That uses these two types. And we need to update the storage and account itself. If we look closely to SushiSwap and MasterChef contract, we see that user has the staked amount and reward debt. So we also need to have these two fields in our records. Yeah, so we will just add staked field and let's say last reward per share. As I mentioned before, here we just have reward debt, but it's not really convenient name for my opinion. And as we saw in deposit function, let me find it. This is just multiplication of current user amount to accumulated sushi per share. And I think if we just store this value instead of this multiplication, it will be even better. It will be more it will be easier to understand. So we store last reward per share here. It will be of type NUT, and we will update the storage itself. So according to this storage design, we will need to look at pool info and have two extra fields such as last reward block and accumulated sushi per share in our protocol. So last updated time, because as I said, we can't get the block where transaction had been approved, right? But we can know the time of the block. We can know the timestamp. So it will be of type timestamp. It's a built-in type in Lego and in Michelson. We will have total staked amount. Because unlike in the Solidity, we can't know. Well, we want to implement inter-contract communication, so our token is actually the token that we stake. So we want to call another method of another contract to know how many tokens are on our balance and in our pool. So we need to keep the field for it in our storage. So we have total staked, and we will have reward per share. And one more thing is we need to know how many tokens will be distributed per each second. So reward per second. Let's say per second. Let's say we are going to distribute 1 billion tokens per 1 second. It's like that. Remember, we need to add this n in the end of our literal to show that it is a natural number and not int. So it seems like we have everything we need. Also, we need to update our getAccount method because now we have 2 more fields in the record. And that's why we need to update the default record that is returned from this method. And it will be these 2 fields. Yep. And we need to add 2 entry points in our main function, which is stake and unstake. Yeah, so we add 2 more entry points here. And just to make it easier to test and to check that it can be compiled, we just return the previous state. And now we will try to compile it. By the way, I see the question in the chat. Why social reward is divided by 10? For a quick answer, I can say that it's used for I'm not sure that they are divided by 10. They are multiplied by 10 in some power. But it's used for like accuracy, right? So it's used for accuracy because we won't have any flawed numbers in Solidity, both either in Solidity or in Lego, and that's why it's better to multiply it by some big number to store the rests. Yeah, so mostly such things in any contracts are done just to keep as many numbers as you can. So as you can see now, the contracts are compiled properly, and that's why we can continue working on our functions. Next function that we will try to implement is that function that updates the pool. And in our case, it will be called update reward function. Because we won't have many pools, and we will stake only one single token, which is our contract. Yeah. So function update reward. And we will need to provide the storage only. By the way, you can notice that sometimes I use const storage and sometimes I use var. In fact, in Lego, if you modify const, nothing will happen and compiler won't say you anything. And mostly it's designed only for developers to realize whether you should modify this variable or argument or not. And I used to type const by some reasons. So we have prepared the block for the scope for our function. And now we need to think a bit of what will be happening here. First, we need to ensure that the time, there is some delta time from our last update. So we will just check it. If as last update time is less than current time, then Tezos now, then we will do some actions. Otherwise, just skip it and then else. Sorry, else escape. Then, if actually we see that some time passed, then we need to check whether we actually have some staked amount. So if total staked bigger than 0, then we do some actions. Let's skip. And in any case, we need to update last update time. Yeah. Now we need to update reward here, and let's just define or declare the variable new rewards here. New rewards. This will be calculated as multiplication of data time to our const, which is called, let me find it, reward per sec. Yeah. So data time multiplied by reward per sec. This is the reward during for that period that had passed. And we need to find this delta time. We'll create another constant for this purpose. And I forgot to set the time. Not. And delta time will also of type not. And we will calculate it as subtraction of Tezos now and last update time from our storage. So this is how many seconds have passed since our last update. And one more thing, as you see, we have subtraction here, and we will receive not as usual. So we need to convert it to unsigned integer with ups operator. And now we need to update our reward per share. And to do that, we will simply add the new value, the new part, that it should be distributed between all the users of our platform by adding new reward divided by total staked. So as you see, we have all the rewards. We divide it to total staked, and that will be the piece that the user will receive if he staked some token on our protocol. Yeah, so I think this function should be correct right now, and we can try to compile it. But it's not. Let me check last update time. Update time. I think I need to check it to fix it. Yep. Yeah, so it works. Now we will define the another function, which is called stake. And we will provide the value that should be staked of type not. And as usual, we will provide the storage here. And we will return our storage. Exactly. So what should we do? First of all, as we saw in the reference implementation in SushiSwap, we need to call this function in the beginning of our current function. We will provide storage there. Then we need to update users' reward, if any. To do that, we will see how many tokens the user should receive. For that, we will declare first of all, we need to read the account of the user. Let's do it in this way. Right. And let's calculate how many tokens should the user receive. New reward, right? And it will be like that. And we will multiply account staked amount by the current reward per share. Reward per share. But it would work only if the user stakes in the first time and in the beginning of in time when the platform is launched. If it's not the first time when he stakes, we need to calculate not just reward per share, but the delta of the reward per share that was in the beginning when the users just staked his tokens and in the current time. What I mean, I think it's easier to code it instead of talk about it. We need to use fast reward per share. And once again, when we subtract something, we always need to convert it to not by this operator. And actually now we will receive the reward that the user should receive. And as soon as we add extra functionality such as stake and unstake to our token, we won't generate any operations to other contracts to send tokens, rather than just update the balance of the user that is stored in the account record in our ledger. To do that, we simply update field balance. In this way, account balance plus reward. And now we need to ensure that the user actually can stake this value. To do that, we check that the balance, if the balance is smaller than the value, we will raise an error. File with balance too low. Also, skip. So if there is enough tokens on the user balance, then he can stake them. And now we will update the balance. We will charge this amount from the balance, like that. And put them to the staked amount. As you can see, we have updated the staked amount of the user on this line, and we have decrement his usual balance on this line. Also, we need to remember to update last reward per share to calculate the delta of reward per share next time when the user will either stake or unstake his tokens. Just reward per token. Oh, per share. And we should remember that account AUK is actually the local variable. And in order to update the storage, we need to do it explicitly. Ledger. To the sender. So count, and I think it should work. Yeah. Let's just try to compile it. Something's happening in chat. For the yield farming part of the smart contract, who is the caller of this code? I mean, is there any kind of automated process? No, it's not automated process. The user that has his tokens call stake, and then he just stakes them, as you can see. So Tezos sender is just any user who has some tokens on his, I mean, in his ledger. So it's not an automated process. Yeah, so as we can see, the code is compiled properly, and we can move on to the next function. And by the way, I will just update this line. Yep. Stake, and we will provide the argument here. So it still should work. How about update rewards? Who calls that? The user who wants to stake or unstake tokens. You see, we call update rewards every time that when any user of the platform made stake or unstake. And by this action, he updates the whole system. So it's a small action, and he won't pay a lot for it. So we won't need any bot who would update it. It always will be updated when someone is interested in such a functionality. All right, so I think we can move to unstake function, which is a little bit similar. Unstake, right? We also need the value, but here we need to ensure that user has enough staked amount before updating his reward. Like that, staked is smaller than we will fail. Otherwise, we will continue. Then we update reward of this user in absolutely the same way. But here we can make some small optimization. And actually, we would need to do two operations: account balance plus reward and account balance plus value that comes from the staked amount, right? Because we want to unstake some tokens. And we can combine these two steps just by removing this part. So we'll update balance by adding to the previous balance reward, and the value is that is unstaked. And we update the unstaked amount by decreasing this amount in this way. Cool. And we remember to update last reward per share, as we did before. And we update the account inside of the ledger. Indeed, it is everything that relates to unstake functionality is pretty easier. Yep, and here we just put the parameter and try to compile this code. I hope I didn't miss anything. Cool. Seems like we coped with all the functionalities that relates to farming, and user just can come and stake his tokens or unstake them and yield some reward. You know, do you have any questions related to this part of our session? Well, I see no questions so far. Then I will move to migrations part. If you just come up with some question, you can write it in the chat, and I will see it. And now we need to update our migrations because our storage architecture had been changed, and now we need to actually reflect it here. Let's look at our new storage. We had added three new fields. I'll just copy them. And we will add them right there. And so. And I will add them here. Our initial total stake will be 0. Reward per store will also be 0 because we don't have any staked amount and we don't have any reward when we just run our platform. Last updated time, as you see here, it would be cool if we put the real time here, but it's not necessary because it will be updated when someone calls stake, because then updated reward will be called. We will see that if last updated time is smaller than it is now, then it will be automatically updated at this line. So we do not need to put real time in our initial storage. Yeah. So we just put 0 here. And we need to update the records in Ledger. We had added 2 fields here. And all the staked amount will be actually equal to total staked amount, which is 0. And total and last reward per share will also equal to last update time, which is 0. Nothing special about it. Now we can try to ensure that it can be migrated. We will run truffle migrate. And it works. It sees that the contract had been deployed, and we can use it. I will add some tests to ensure that our functionality works as we expect. We'll add the folder tests, and we will add some file, general. And I will copy the file that we had created when during the last session, I'd say. We will continue working with this file, and we need to install this package before. But now we can continue. As you remember, we have checked the initial storage, then we transferred some tokens, and check that the function will fail. And as I said, there is a whole test suite, and all these tests are executed on the same contracts, on the same instance. And when we update the storage in any of these functions, in any of these tests, it has an impact on the following tests. So when we add the new test, we should remember that the balance of Alice is not 1,000 tokens anymore. Now it's 900, and we should take it into account. Yeah, so let's add a new test that will ensure that stake works. Should stake the value, the tokens, let's say, for Alice. Yeah, so we will need an instance here as well. We will need Alice address. We won't need Bob address. Value will be the amount that we will stake. We also will read the storage. We will need Alice record. We won't need the Bob record. and we won't need this check. Now we need to update transfer operation by stake operation. The only parameter is needed, which is value. And we will check balance. We will check stake it. We will check what we have else. What else we have? Last reward per share. Yep, and also we need to check some storage parameters. Yep, we'll do it like this. Storage total supply, total staked, reward per share. What else we can check? I think last update time is also interesting. So yeah, we will check it too. But so let's start with some simple things like this. It's much easier to check. And to do that, balance should be 800. Staked amount should be equal to value. Total supply should stay the same, 1,000. Total staked should be equal to value. And actually, that's it, right? And probably if we run shuffle test, it would work or not. Let's see. And just won't work. As we see, there we have an error. 900 is not equal to 800. So it fails on this line, and it seems like the Alice balance wasn't updated, so the tokens hadn't been charged from the Alice. Why did it happen? The reason is simple, because we had updated Tezos signer provider at this line, and now the center is actually not an Alice but the ball, and we need to fix it before the test. That's why it's much better to create a separate test cases when you update something in your environment. But my point was to show you that. So we will update the key here. And now the Alice will be active. And these tests should actually work now. Why not? Yes, sure. We made a mistake. I forgot to update total staked here. Not this one. We need to add the line here. Total staked should increase. Plus value and should decrease right there. Or there. I think it's right here. Minus value and yeah. I bet. Yeah. Now it should be better. That's why tests are really useful. Yeah, cool. So as we see that we can test some functionality here. Now we need to test last reward per share. Last reward per share should be 0. Yeah, I forgot to uncomment it. Because it's initial stake, and when the update reward is called here, we will go to this flow, this I would say branch, and I'm not sure. So we will go to this branch, Then we will see that there is no staked amount, and we will just update last updated time. And we want update reward per share. So it will be equal to the initial value, which is 0. But what is interesting here is how to test, and yes, reward per share will also be equal to 0. And how to test last update time. You can guess that we can try to read or know the data on our current machine and try to compare it, but it won't work because last update time will be equal to the time of the last produced block. To test that, we need to read the current time. We will create a separate variable for that, current time, and we will recall that we have such a global variable such as Tezos, and we can use it for some of our needs. Tezos has a member RPC that has some interesting methods here. So we can call the RPC and know something from the blockchain. Actually, we can look at node models, go to Takita, to RPC, and look what we have here. Types, Takita RPC. So we can read a lot of interesting information with RPC, such as get block hash, get live blocks, get balance, get storage, and blah, blah, blah. But we need to get block hash, which is there. And if we want to provide any data, it will return the last block in the blockchain, and actually block header of it. And here we have timestamp of type string. So it will return us the string as it contains the data of the last produced block. And we will need to convert it to actual timestamp. So it's what we will do. So test RPC get block hash. Get block. Sorry, how do you call it? Get block header. Get block header. Timestamp. Yep, timestamp. And we will use data parts, right, to convert it to timestamp. And you should remember that this current time will be of time in milliseconds, not in seconds, just for your note. Then we need also last updated time is of type timestamp, and it will be in string, so we will convert it to timestamp to compare them. Data parts. Sometimes it's really hard to think and to talk at the same time. So data parts and current time, and now I think it should work. Yeah, so we see that all the fields in the storage and in Alice record works like we expect. Now we will test another interesting functionality is reward distribution. And I think we will copy this function, this test, and try to think what we can do here. Well, these tests are around one by one, and when this test is run, the Alice have some staked amount. But actually, only one block had passed since her stake, and it's not interesting to see how many tokens will be distributed in one second. So we need to create some functions that will help us to make some time travel. Unfortunately, the truffle does not have such awesome functionality as you can have in Ethereum with truffle, I mean. That's why we need to create our own time travel function. I will call it, let's say, I don't know, bake blocks, because creating blocks in Tezos is called baking, this process, I mean. And we will create some function bake blocks. We will provide number of blocks that we want to produce, or we'll let so we simply will create some transactions, and it will make our sandbox to produce some blocks. Yeah. If we run tests in a real network, we won't need to make these bake blocks. We would just wait until some blocks will be baked. But in case of sandbox, when blocks are produced by daemon, when some transactions are sent to the network, then we need to create some, simple transactions to emulate block creation. Great. We need to create transactions. So we will use Tezos again. We will use contract package from it. Contract, let me call it contract transfer, contract transfer to. And we will send some amount of tokens to ourselves. Let me find it. Well, doesn't matter. Does await Tezos signer. Actually, with this call, we will receive the address of the sender, and we need to specify amount. Let's say 1 gas. Yeah. So we will do some simple transfer here, and this function should be awaited. And moreover, it will even return some information about the operation. So we can do this, and we will await confirmations of such an operation. Await operation confirmation. I think so. Yeah. And we will use this function in our test here. Also, we won't need this anymore because we had changed the signer at this line. And now we will stake nothing. We will use stake only to update the reward and to see that the balance of Alice had raised. We will need current time. We will also need the previous storage. Let's wait. We will need the previous storage. We will call it before the stake. Current storage. Yep. We will make some blocks before our stake function. Just here, await blocks. Let's say 3 blocks. Then we will see the time. We will make stake. We will get the new storage. We will get the new Alice record. Sounds good. But before, we need to calculate how many tokens should be distributed during the time that had passed since the last stake. To do that, we define new variable, which is called reward per share. And we will calculate it as usual. reward per sec multiplied by delta time. But as we see, we need to define reward per sec, which is 1 million here. And we need to calculate delta time. To do that, we use the current time minus brief storage last updated time. But as you remember, it's of type timestamp, and that's why we need to parse it here. And as I mentioned before, it's in milliseconds. So we will divide it by 1000. So now delta time will be in seconds. So that's what we need. Now we have reward. No, it's not reward per share. I'm wrong. It's reward. It's actually new reward. Yeah, and to calculate reward per share, we need to divide these rewards to total staked amount, which is 100. 100. And if you're listen to me carefully, we won't have any odd numbers, and it's always rounded to 4. So reward per share will be calculated as it is. And then we need to calculate Alice reward so far. To do that, we will multiply her 100 staked tokens to reward per share. And then her balance will be actually this liquid 100 tokens plus her generated reward. Ticket amount will stay 100. Last reward per share should be equal to reward per share right now. Yep, and total supply should be 100. Total staked should stay it's not 1000 here, 100 here. Reward per share should be equal to reward per share. And I think we won't need current time. Yeah. So I guess it should work. I'm not sure, but let's try. Yep. So there is a mistake here. Let me check. Public key hash. Maybe it's called in a bit different way. Signer. Yeah, it's just public key. It's wrong. Yeah, I made a typo here. Public key hash. And operation not confirmed are probably confirmations. Confirmation. I can actually check it. Well, let's just try information. Or confirmations, I'm sure. It's pretty sad that we can't just go to the package and find it. It's too long. Yeah, so it works. And I think I need to update the message here just to make it clear, should assess the reward for Alice properly. Well, should assess the reward for Alice. Yeah, so actually we have test stake functionality, we have test assess reward functionality. Now we just need to test unstake. And to do that, we need to update something in this function. First of all, we update the message. Should unstake tokens for Alice. Then we will still make some new blocks. We will use this, and unstake function should be called here. We also define or declare the variable value, which is equal to 100 tokens that will be withdrawn with unstake call. One more thing is that we need to update expected balance. It now will be Alice reward plus this amount. Also, I think it's even not, no. I think it's better to read the previous balance and add new Alice reward. Let's say new Alice reward. Or, well, let's call it Alice reward, but it will be plus the withdrawn value. And ref Alice balance, let's say, is called in this way. Ref Alice balance. Yeah. We will read this ref Alice balance. Let me find it. Here, yeah, we will get ref Alice record here, right? Let's say storage ledger get and Alice address, and then ref Alice balance will be equal to ref Alice record balance. Yep, because I want to show you that the previous balance plus previous reward plus current Alice reward and plus value, that is what is on the new updated Alice balance. Then staked amount should be equal to 0 because we withdraw everything. Reward per share we will recalculate. Total supply will be equal to 1,000. Total stake will be equal to 0. Reward per share will be equal to what we will calculate. And here we also need to update reward per share, because it will be calculated not just by dividing rewards to staked amount, but also we need to add the previous reward per share. And we will read it from ref storage. Yep, ref storage. Reward per share. Share. Yep. So reward per share will be calculated as the new generated reward plus previous reward per share, and Alice reward will be calculated as new reward per share multiplied by her current amount. But now we need to actually not just use reward per share, but the delta of this reward per share. So it's just like reward per share minus ref Alice record last reward per share. Last reward per share. Something like that. Let's review it again because the code becomes huger and it's hard to control it. So we have an instance here. We have Alice balance, pref storage, pref Alice records, pref Alice balance, values that will be unstaked. We bake some blocks, but we need to do it a little bit earlier before we read the storage. Then we read the current time, we make unstake, then we calculate the delta time, the time between our call and previous last update time, and we make sure that it's in seconds and not milliseconds. Then we calculate the reward that should be distributed during this period of time. Then we calculated new reward per share. We make sure that we add the previous reward per share, because reward per share always grows with reward, yeah. And we calculate Alice reward by calculating the delta between her previous reward per share and the current reward per share, and multiply it to her current amount. So we read the storage, we get the Alice records, we ensure that her balance is equal to the accumulated reward and withdrawn value plus her previous reward, and balance, yeah. And stake amount should be 0. Last reward per share should be equal to the current reward per share. Total supply should be equal to 1,000. Total stake should be 0 because we withdraw all the tokens, stake it in the platform. And reward per share should be equal to the current reward per share. Sounds rational. Let's just have a go and check it. So let's just look at this line. What's wrong? Oh yeah, sure. I should use pref storage here. And in other cases, should be better. I'm a bit bored to wait for all the previous tests before the checking the last one. All right, so we see the mistake somewhere in line 125. Let's see what's going on here. So the balance of Alice is actually smaller than what we have calculated, and we need to see why. Let's see. I guess Alice reward value I guess something wrong is with Alice balance, because if we think logically, this amount should be, well, let's check. No. This one, I think we calculate expected value a little bit in a wrong way. So what we have here, Alice reward is equal her amount multiplied to reward per share minus per Alice record last reward per share Maybe reward per share is wrong. Let's see. Reward per sec, delta time, per storage, last updated time, current time. Interesting. It seems to be a little bit bigger than I expect. Is delta time calculated properly? Let's just look at it. Reward per sec, reward per share. All right. So delta time is calculated properly because 4 blocks had been baked between these two transactions, such as Unstake and Stake. And then reward per share is a little bit bigger than I would expect. Like, yeah, it's kind of too much. Let me look at, or not, let's see. Yep, 4. In fact, here we have the proper answer, but then we add reward per share here, which is bigger, which is too big, I would say. Well, oh, yeah, I see mistake. 2 number. I think it's interpreted as the string. 2 number. I guess that is the reason why I have this issue. And yeah, I guess last reward per share. Yep, I think that is the case. Well, now we have finished in another place. Let's see. This line. So I guess something kind of similar. Proof balance, yeah, we need to use this stuff. It's so interesting. Yeah, so that is success, I would say. So yeah, we have created the farming for our own token, and we have tested this solution, and we see that it works fine. So actually, that's all I wanted to show you today, and yeah, help you to summarize all you could learn during this crash course. I hope you enjoyed it. So if you have any questions, you can ask me now.
Hey, everyone. Anyone have questions? Competition questions, token questions, Bitcoin Suisse questions, Bakery IL questions, weather questions?
By the way, I will push all these changes to the GitHub that you have probably know in a separate branch, I guess. Yeah. So you will be able to review it all. Yeah.
Great. Thank you, Anastasiia. Also, yes, for the competition, please put it into a PDF format and email it into contact@tezos.co.il. You guys will have to the end of day Monday, plenty of time over the weekend. Don't sweat it if you've already sent it in. Take your time, send it back, or don't. I'll use the one that you sent in. It's your choice. If you want more time. And I think that wraps up our Build Your Own Tezos Token workshop. Thank you so much to MadFish.solutions, to Anastasiia, to Corny for everything that you guys have done to put together this wonderful presentation over the course of 3 days. There was a lot of effort that went into getting this together for you all. All the recordings are going to be available online. We're aware of the day 2 session, so we're going to check into that and get that fixed. And if you have any further questions, comments, want to reach out, etc., we're available on Twitter, on our Discords. Use the Stack Exchange for asking questions. And thank you all for coming. The swag bags will be mailed out to you guys. And we will need to get your Tezos, your TZ addresses for the digital certificates that we're going to be handing out. We're about to post it on Twitter sometime soon and make an official announcement to the world. So you guys have a little bit of a heads up on that. We went live on the mainnet last night, as I said earlier, and you guys will be the first to get a digital certificate on Tezos in the world. So congratulations, Anastasiia. Thank you so much for this evening and the previous.
Thank you, too. Yeah.
And have a good night and day, everyone. Bye-bye.